Hello everybody, I will start my today another coding practice. So in this video, I will solve this question, maximum subarray. So in this question, I'm given an integer array nums, and I will find the subarray with the largest sum and return its sum. Okay. Cool. And for the definition of subarray, it's the contiguous non-empty sequence. So say if I'm given nums like 1, 2, 3, 4, 5, subarray is something like maybe 0 or maybe 1 2 or 2 3 or 1 2 3, but it isn't 1 3 or 3 2 1. For 1 3, I skipped number 2, so it isn't valid. And 3 2 1, obviously it is reversed, so it's invalid. Okay. And the constraint of this question is that, as I can see, the number can be negative. I think it's one of the things I have to think carefully. And aside from that, yeah. I think so these are the things I should take care. Okay, so let me think of this question with some examples. So let me quickly say this one first. So if the number in the array is only negative number, I should return 0. Yeah, because I should take empty subarray and I should return 0. I think this is one of the edge case I have to take care. So I now first write it so that I don't forget it. Okay. And aside from that, let me think with some example. So I think in this question, I will take a look at each number from the, head. And I always have two choices. Whether I should start from this number or, so, okay, I have two choices for every number index while I'm traversing in this order. So, for example, if I find -3, I have two choices. I should take it and then continue the currently ongoing subarray. Maybe it is empty, yeah. Or I don't choose it here and start from the next, element. So these are two choices I have. Yeah. Okay. And if I decide to choose -3 here, it means that, so current number is added to the current sum. And also, if I decide that I don't choose the current number, current sum is reset to 0. Okay. And obviously, I should decide if I should take the current number or not just by checking if, this one, current sum plus nums I, becomes negative or not. If it is negative, then I should throw away and I should start from the next, index with 0, because 0 is larger than negative number. But if, say, like this, if the current sum is now 3, which is larger than 0, so definitely thinking of the 4, it should concatenate it with 3 to -3, and not, it shouldn't start with 4. So that's the basic idea I can use. So I think I can use the dynamic programming here. So first I can say, let me do it. As I said, I have two choices. So now current sum is 0. It begins with 0. And now I have two choices. I will pick -3 or not. Definitely I shouldn't. And still current sum is 0. Which means that when I take 2, it begins with 2. And here, definitely I should take 2. And current sum becomes 2. Then, okay, let me say, like this. Here, definitely I should take it. Yeah. Because it increases the sum, and also it is variable for future Subarray. Yeah. But here, what happens is that if I take this -10, the current sum becomes -4. I shouldn't do that. And I can say the next number should start with, that number only. So if I take -10, the current sum should be -4, and it's better that I don't take anything. So I reset current sum with 0, and then here I should definitely take it. So current sum becomes 5. And that being said, what I should return is the maximum of current sum. In this case, it is 4. This is exactly the segment which begins from this 2 and ends with this 4. Okay, so that's the basic algorithm I can use. And so time complexity should be O of n, assuming that the number element is n. I did the linear scan, and for space complexity, it should be constant. Okay. So current sum plus equal num. And if or maybe I should say, I will think of current sum plus num, and if it is larger than 0, definitely I should take num. So in that case, it becomes this. Otherwise, I shouldn't take this current num. So current num should be reset with 0. Then I should update max num with current num. Yeah, because maybe the current number is the end of the longest, subarray with the max sum. I always have to update max num with this. And finally, I will return the max num. Okay. So let me quickly think with this example. In this case, the maximum Subarray sum is 8. I will check it. Firstly, max sum is 0, current sum is 0. Yes. And when I take a look at number 3, because current sum plus num is 3, which is larger than 0, So I increment current num with num. So wait, current num. This will be current sum. Now current sum becomes 3. And in line 34, I update max num with current sum. So definitely it should be 3. The next thing is that I will take a look at next num, which is -5. And current sum plus num is now 3 minus 5 is -2. So I don't want to take this num. Yeah, it's better that I don't take anything before this number. So now current sum is reset with 0. And max num is updated with 0, so it's still 3. Then the last step, I will take a look at 8. And yeah, obviously 8 with 8, current sum plus num is now 0 plus 8 is 8, which is larger than 0. So now current sum is 0 plus 8 is 8. And in line 35, I update max num with 8. This becomes 8. And I will return 8. Great. So I think I've covered all the lines in this implementation. So let me execute my code. Oh, sorry. This should be max sum. Great, and I will submit it. Wait, where is it? I think I updated max sum with... Oh, this seems like empty array is not allowed as the subarray. Yeah, so definitely this is, wrong assumption. So let me think how I can avoid this. I think what I can do is, firstly, I initiate this max sum with the first element. It can be, actually, it can be any of num in the nums array. Then I update the max sum only if I take this number. Yeah. Here in line 31. Otherwise, if I don't take num, I don't update max sum with 0. Yeah. Okay. Now let me test. Okay, with this, in this case, let me quickly walk through. So now max sum is -1 and current sum is 0. And in line 27, I iterate with num -1. And now current sum plus num is 0 minus 1 is -1, which is smaller than 0. So I go to line 33. So my current sum is 0. And I go out of the loop and I return max sum, which is -1. Looks good. Okay, I will submit my code. Okay. Wait, where is it? So if this is -1, it's better that I don't take it. So I start with -1 next time. I see. The problem here is that I said if current sum plus num is, larger than, smaller or equal to 0, I shouldn't take it and continue. However, there are some cases that even with that, I should take this number. So, okay. let me say. The problem here is that if I take the -1, so in this case, I start with max num -2 and current sum with 0. And when I encounter -2, it's better that I don't take it and start from 0 in the next, iteration. I think it's true, actually. -1 should start from -1. But now -1 thinks that -1 should be included, so that's a problem. So definitely what I can say is if I don't take this num, even in that case, I update max sum with current num. Wait a minute. 1. I think this works. But I think this isn't so clean. Accept it. So let me think how I can organize this code a bit more cleaner. So my mistake was that okay, I see. Let me think of it in this way. So in each step, instead of thinking of the future, in each step, I will think what is the biggest max Subarray sum which ends with the current num. So if I think it in that way, so the comparison I should make is current sum plus num versus like this. Yep. Then I should update max num with this number. So if I do this in each step, which means that I take a look at every max number which ends with each index. I can cover all the possible max num candidates. And after that, current sum should be just this max sum ending here. Yes. Definitely, I should take this over to the next element. I can take 0, obviously. Okay. And also here, max sum ending here, max sum ending here. Good. Number is accepted. Yes. So this is also O when time compressed. Okay, so now I find the follow-up. If you figure out the Owen solution, try coding another solution using divide and conquer approach, which is more subtle. Okay. What does it mean by subtle? Elegant. Okay. I think if I try to solve this question with divide and conquer approach, I will divide into 2 first, and I will think of this range, and also I will think of this range. And for each range, what I should return is, there's 3 things I'd like to return. I mean, think. Number 1, max sum of every possible, and max sum which start with the left boundary of the range. I should say maybe suffix max sum, and also prefix, and also I need suffix pre-sum. Yeah. So if I return this, so let me think of this in this way. So say I'd like to know the range of the maximum in this, yeah, range. In that case, here I guess the maximum here and maximum here. The max sum of this area should be the max of, let's just say, let me say this in way. So I can say the max sum of the whole range be, the max of max sum 1, max sum 2, and suffix max sum 1 plus suffix prefix max sum 2. Yep. And prefix max sum 1 should be, prefix max sum should be prefix max sum plus, maybe prefix max sum is exactly the same as this sum. Yeah, I can concatenate with the suffix of max sum 1. Yeah. So maybe also I should return range sum also. Yeah, so with that being said, if range sum is equal to the, range sum 1 is equal to prefix max 1, the prefix max sum should be prefix max sum 1 plus suffix max sum 2. Otherwise, it should be prefix max sum 1 only. Yep. And for the similarly in suffix max sum, the suffix max sum of this range should be suffix max sum 2 or suffix max sum plus suffix max sum 1 if suffix max sum 2 is equal to range sum. Yeah. I think this is how we can solve this question with divide and conquer. And with divide and conquer, the time complexity should be n log n, because every time I divide the string into 2, so number of height, I will do this operation. I should say, if I take a specific number index, that number should be included in log n times. And it's same for each character. So it should be n log n. And for space complexity, what I need is only the recursion stack. So it should be log n. Okay, so run Mr. implementation. Because max sum is at the head element, it should be index 0. Okay, so let me get started. So if low is equal to high, I should return this. Otherwise, there are few elements. I should do divide and conquer. So the first approach, first, like this. So if low is 1 and high is 2, it should be 1 to 1 and 2 to 2. Yes. If it is 1, low is 1 and high is 3, it should be 1 to 1 and 2 to 3. Okay, looks good. So I should get these by calling this function recursively. Yep. Then from here, I will guess the current ranges these 4 attributes. And after that, I should return this. Okay. So as I said, max num should be max of max sum 1, max sum 2, and suffix max sum 1 plus prefix max sum 2. Then for prefix max sum, it should be prefix max sum 1 plus prefix max sum 2 if prefix max sum 1 is equals to max sum 1. No, range sum 1. Yep. Otherwise, it should be prefix max sum 1. Okay, then for suffix max sum, I do a similar thing. Like this. Okay, and in the end, for range sum, I just have to add the range of two range sums. Okay, good. So let me execute my code. Oh, sorry. Went it out. I have to. Okay. So now it's wrong. Let me quickly walk through my code again by myself. Oh, sorry. Yeah. Mm. Max sum 1, max prefix max sum, suffix max sum 1, range sum 1. I get this. Yep. Then the max sum in this range should be, I will compare this, this, and this, and this. Looks good. Prefix max sum, I should add this and this if prefix max sum is equal to range sum 1. Yes. As I was prefix max sum 1, yes. For suffix max sum, I think this is good. Wait, this isn't correct. Because I mean, if max sum is quite large in some area, like this, and if I merge this with this, in this case, when I take a look at this, max range should be this to this, and this should be this to this. This is the max sum in each range. However, if I try to get the maximum range of the all merged interval, I mean range, it should be not the sum of, I mean, I should take negative one here. So that's the biggest difference. So probably I have to consider this case also. I see, I understand. So for max sum, I should compare this, and mm, this and this, and also I have to think. No. Okay, so what I try to get is maximum sum. Accept this -1 and merge these two cells. Or maybe like this. Oh wait, but in this case, here's the suffix max sum should be this. So maybe I covered that case in my solution. Now I'm thinking so. So still the case I was wondering that I should accept this is covered in, where is it? This and this. Sorry, this. But I think prefix max sum maybe this isn't correct, because even if prefix max sum isn't range sum 1, I think there are some cases that I accept this and add the suffix of the second half sum. I mean, suffix sum of the second half. Same for suffix max sum. First case is I just take a look at the suffix sum of the second range. However, also I think there is a case that I should accept this and I should take the suffix sum of first half, even if, I mean, the prefix, I mean, suffix max sum isn't range sum. So I can simply say this should be this. And for this should be like this. Okay. Let me check it again. Good. And then we submit again. So in this case, let me take a look again. Prefix max sum is prefix max sum. No, sorry, this is range sum. And for this should be, here should be range sum too. Yep. I will test on the case I missed. Okay, now it's good, so I submit again. Okay, great, and now it's accepted. Okay. So I could also solve this question with divide and conquer approach. So now let me wrap up my today's practice. So today's question was maximum subarray. And in this question, I'm giving an integer array nums and I will find the subarray with the largest sum and returning sum. Yep. So I introduced two approaches for this question. The approach number one is using the dynamic programming. And the second approach was to use the divide and conquer. Okay. And for dynamic programming approach, I use linear scan for each number. And every time I see the number, I will think of the maximum sum which ends with that number. This is the key. This makes the direction of implementation so clear, and I can avoid the edge cases. But unfortunately, I didn't come up with it first. I made a mistake, but basically that's what I should do. And for each num, I will think of the maximum num, which of the subarray, which ends with that number, and I will update the global max sum with that local max sum. Then I will return the global max sum of subarray in the end. And the second approach I introduced was using the divide and conquer. For divide and conquer approach, I returned these four attributes from each range operation, recursive function. And based on these results from first half child range and latter half child range, I can now calculate these attributes of the current range, or I should say merge the range. And I do divide and conquer. And finally, I return max sum of the any subarray, which is one of the attributes, which is returned from the recursive function. Okay. Good. I think that's it. Yep. So let me finish my today's practice with this. Thank you so much. Bye.